Okay. Good morning, everybody. I'm Giovanni Coppini. I'm the director of the Global Ocean Coastal Ocean Division at CMCC, and I will be the moderator of today's webinar that will be presented by Giusy Fedele, and it will be about evaluation of atmospheric indicators in the Adriatic coastal areas, a multi-hazard approach for better awareness of the current and future climate. So I will introduce the webinar through a presentation about CMCC, and then I will give the floor to Giusy. So CMCC, it's a foundation, is a research foundation, which main goal is to investigate and model our climate system, and with a focus on the interaction with society to provide reliable, rigorous, and timely scientific results. And the final objective for us is to stimulate the sustainable growth, to protect the environment, and develop science-driven adaptation and mitigation policies in our changing climate. Recently, in the last year, CMCC has been restructured, and here I present to you the three research institutes which are working together. The first one is the Institute for Earth System Predictions, and then we have the Institute for Climate Resilience and the Institute on Economics and Environment. And all these three institutes works together to perform the research, and they collaborate in a highly multidisciplinary environment. Of course, all our work, or most of our work, is based on our capacity, the supercomputing capacity. Here, the highlights of our center. The first supercomputing was started at CMCC in 2008, and then has grown and is recognized as being the most powerful computational facility in Italy and among the most advanced in Europe, fully dedicated to climate change research. Recently, the new supercomputer has changed the location and now is in Lecce in the CMCC headquarters. And this step also included the upgrade of the storage and the computing facilities itself. You see here the numbers, which are impressive, especially if you consider that it's fully dedicated to climate change research. CMCC is distributed over several offices in Italy. Here you see in the map how well we cover the Italian territory. And we should consider it as a network that it's also able it's a connect to the territory and to the public and private entities, and then work together in performing multidisciplinary studies and also trying to focus on the interest of society and climate science. So the members and institutional partners are here listed, and they range from a research institute to main university in Italy dealing with climate change. Here you see, and then we also collaborate with the Resources for the Future, which is a US institution. So to come to the seminar, you will be able to interact with Giusy and myself through the Q&A session in Zoom. And so you can use this Q&A to provide questions during the seminar itself. And at the end, your audio is deactivated, but in case I can, you can raise your hand, and then I can give you the floor if you want to speak with Giusy. But please use the Q&A to comment and pose questions to Giusy. So with that, I finished the introduction. Of course, you can pose questions also to me on CMCC. And then I stop sharing and I give the floor to Giusy. She's a postdoc at in the ICR Institute at the REMI division. And please, Giusy, the floor is yours.
Thanks a lot, Giovanni, for the introduction, and thanks you all for being here at this webinar. So it's very nice to present this work today. And as Giovanni mentioned before, it is about the evaluation of atmospheric indicators in the Adriatic coastal areas, a multi-othered approach for a better awareness of the current and future climate. This work has been done within the Adriatic project, which just ended the last June. So I'm going to present you a part of the work that has been done within the project, which I want to here to present you. So first of all, what is Adriaclim? So Adriaclim, as says the same, its same name, is composed by two main words: Adria, that stands for Adriatic, and Clim, that stands for climate. So it is focused on the Adriatic climate, so, and investigates mainly the Adriatic region. So this because the Adriatic Sea is a climate change hotspot, and it's really important actually to investigate the coastal areas and in order to better to provide to stakeholders and information related useful to support the development of science-based regional and local climate change adaptation plans. So the main goal of this project is therefore to provide new, updated and accurate information in terms of new observing and modeling system in the Adriatic Sea. And this has been done with the collaboration of 19 partners here shown. So I would like also to thank all the partners involved for their work, and also the coordinator, Andrea Valentini from Emilia Romagna. So just to give you also the flavor of what has been done, I would say that I would summarize, first of all, that the main goal of the Adriatic project is to improve climate resilience in the Adriatic region. And so to do that, let's say that three are the main steps. So first of all, to deliver new climate information at high resolution over the Adriatic region, both in terms of new monitoring system and both in terms of new climate integrated models. So here, for instance, in this slide, you can see the new mooring station installed at Torre Guaceto, and also the new regional integrated model that has been delivered within this project. The activity related, the modeling activity have been conducted, have been coordinated by OPA division, and I want to thank also Giorgia Verri for her work. So all the work I'm going to show you is a matter of a very strong collaboration within CMCC and also outside it. So After second step, I would say, is the development of climate hazard indicators of the Adriatic region, and which is really important in order to support adaptation and mitigation measures of the pilot areas. And then, of course, the third step is the identification of the definition of new measures, new adaptation plans in order to face in the best way possible climate change. So here in this presentation, we will mainly focus on the second part of this presentation, so on climate hazard indicators. This because I was task leader of the task related to the development of climate indicators of the Adriatic region. So that's why just I'm a little bit biased on this part. So the indicator that have been developed cover several data sets. So not only those developed within the project, but also already available data sets. So, and they are of different nature. So we have both indicators computed over regional model and coastal models, such as, for instance, Met-Coordinates, Adriatim, and also reanalyses such as ERA5, ERA5 Land, CMEMS, and EFAS, satellite observation from Copernicus Marine Service, observations such as EOBS and situ observations, situ stations. So other climate indicators being developed for the whole the pilot area that are here shown. So as you can see, they are also around the Adriatic Sea. I forgot to say that in fact this project has been done in it's part of the Italia-Croatia Interreg project. So that's why you see that the pilot area are all surrounds the Adriatic Sea, and we have both pilot from Croatia and Italia. So the indicators, the hazard indicators that have been developed, as you were able to see in the last slide, of course, cover also different domains. So sea, sea, biogeochemistry, atmosphere, hydrology. And all those indicators have been designed, co-designed through stakeholder engagement at pilot resolution. So they cover different hazards such as temperature increase, thermal disease, hydrological instability, coastal erosion. And you can access all this data starting from different data delivery system. There are two systems that have been developed within the project. First one is the CMCC platform, and here I want to thank Alessandro De Donno for his work, and in the geoportal that has been developed mainly from ARPA Emilia Romagna, from Davide Cesari. So the first one, ERDA platform, you can both access the data, download them and use them also for your applications, and also visualize those data on the platform. While geoportal is also is a platform where you can interact at pilot area and visualize all the indicators you are more interested. So I really encourage you to have a look. So then we can now actually move to the part that where I was more involved. So which was also the definition and the development of hazard atmospheric indicators of the entire Adriatic Sea. In fact, I want just to underline that at pilot site, different indicators have been developed, and but also at Adriatic scale, in order to face issues related to single partners that were not able to produce their own indicators. So those partners, for instance, had the chance to access the indicators at wider scale and use them for their applications. So this is a paper that has been just published. Where there is a main focus on the atmospheric climate indicators on this area, and it is about the results of the investigation of the Adriatic modeling the model. So I want to give you here an overview also on the model configuration. So as I was saying before, it is an integrated model system. So we have different components. We have the atmospheric component, which is provided by WRF at 6 kilometer resolution, which is made also by a sub model, land surface sub model NOAA at same resolution, which is coupled two-way coupled with an hydrology and river routing model, which is WRF Hydro. And then there are even other three components: waves, ocean, biochemistry. So with the respectively model Wave Watch 3, NEMO, and BFM. The first thing that have been used to develop all the simulations are provided by Cortex, in particular this specific configuration from CNRS, and this is more. This is just a very brief overview of the modeling setup. As I was saying before, this activity were coordinated by CMCC, by Giorgia Verdi, and so of course I hope to give you the best the flavor of the modeling setup. Of course, in case of any other question or curiosity, I would suggest you also to ask Giorgia for more information. Actually, other papers are also submitted. So also from on the modeling, both on the marine part and biochemistry part. So I'm sure that in a few months we will have a clear overview on the all domains that where we implemented those indicators. So. And I want also to give you the flavor of the work of the atmospheric component, since this is the part that was investigated by myself for the investigation of the atmospheric climate indicators. So, and this model was run first of all through the first step was a pre-processing phase. So all the initial conditions were created in order to run the simulations with WRF NOAA, and so two different simulations have been run. So an historical simulation from 1990 to 2020 with 1 year spin-up, and a projection with the RCP 8.5 scenario from 2020 to 2050 with the 1 year spin-up. Then all these, since it is one only simulation, so one only model configuration, a bias correction has been also applied on few variables such as rainfall, wind, and meter temperature, and consisting in quantile mapping and long-term trend correction. And then afterward, starting from those fields, they have been pre-processed and put within used in order to run WRF Hydro climate simulation. And into run, so historical simulation from 1991 again into 2020, and then the projection one. So, of course, after giving you the overview of the modeling setup, we can move to the model validation. So here I want to show you the main PDF that you, for precipitation, temperature, mean, maximum, and minimum, in order to show you that on the historical period that has been analyzed, the model will reproduce the ERA 5 land features. So both viability. So as you can see here, we used, for instance, ERA 5 land because it is a resolution not so far from WRF. It has a resolution of 9 kilometers, while Adriatic WRF, it has a resolution of 6 kilometers. Of course, an interpolation has been done in order to bring both the data at the same resolution, and then they have been compared to each other. So now actually after validating the model on the historical period, we can discuss what are the results related to the future climate with respect to the past climate. So as you can see here, we have maps of differences between the mean future state and projection state and the mean historical state. So, and as you can see here from the minimum temperature, mean temperature, maximum temperature on the right-hand side, and then the precipitation on the bottom left side, you can see that there is a general positive increase over the whole pilot areas, both in terms of minimum, mean, maximum temperature, but there is a strong increase, especially in the northern northern sector, so both in Friuli Venezia Giulia, Veneto, and Croatia region. So, and while regarding minimum temperature, also peaks of minimum temperature, higher minimum temperature are reached in the southern part of Apulia region. So as you can see, values reaches up to 3 degrees. So it is a huge value considering considered as difference with respect between the future with respect to past climate. While regarding precipitation, as expected, we have a clear heterogeneous pattern over the pilot areas. In particular, a strong decrease in precipitation is found over the Croatian pilot areas and northern Italy, especially in Friuli Venezia Giulia region and Istria. And while positive differences are found more on Marche, Molise, and also on the northern sector of Apulia region. And these you can understand that, of course, in coordinated with the also stronger temperature over the region may lead, of course, to severe impacts. But we will see this in the next slide. So just summarizing the slide, of course, we see that there is a daily temperature difference very high, reaching maximum at 3 degrees Celsius over the northern region, and then also a strong decrease in daily accumulated precipitation, northern Italy and Croatia, and then precipitation increase over Marche, Molise, and northern sector of the region. So now I want to give you also an overview of the seasonal differences for all these variables, so starting from temperature up to precipitation. And then, for instance, the mean temperature, as you can see, for the 4 season is always positive for all the pilot areas, so, but more emphasized, more extreme values are reached in August in Friuli Venezia Giulia and Veneto region, also in Emilia Romagna, and while minimum temperature, for instance, also have more positive patterns, but minimum differences are found also in the coastal area of the Emilia Romagna and Friuli Venezia Giulia region. So in general, we can say that here that the temperature become very high in most of the regions, especially in also, for instance, for Timin, as seen also before, it's clear that there is a clear peak, maximum peak in August in the southern part. So there is a general increase, trend increase, and only few regions are impacted by negative differences, and only, for instance, especially in the winter season. So while regarding the maximum temperature, the differences are even more emphasized in terms, for instance, in the northern sector, very high value at 3 up to 3 degrees are reached, especially in July, August, and September, October, November. So in fall. And so while what also is interesting is this negative peak over the season, over the summer season over the Puglia and Molise region. Regarding precipitation, also what we can clearly see is that during winter, northern Italy's and Croatia regions are more affected by a decrease in terms of precipitation, while the southern and central Italian region are really impacted by an increase up to 1 millimeter day over those regions. So while stronger values are reached, a strong decrease is reached in the northern sector, especially in summer and autumn. So starting from those variables that have been investigated, so temperatures mainly and precipitation, several indicators have been developed, among them that have been also agreed with stakeholders. And here there is a list of those indicators that have been used. So as you can see, I don't want to read all of them with you because maybe it may become too long, but I just want to give you an overview of those indicators and let you see in the next slide what they mean, what they actually provide us as information. So, of course, here we both, with this indicator, we can both have a look to more extreme temperature and also precipitation events, and then, of course, also from taking account also a combination of several indicators, we can get very important information. So, for instance, in case of strong drought, of course, associated also to a strong decrease in terms of a strong increase in terms of intensity and frequency of precipitation, extreme precipitation events. Of course, you know that it may lead to very severe condition in terms also may lead flooding events. So here in this slide, so I want to show you a table which provide differences over each pilot area for all those indicators. Of course, I don't want you to look at every specific value because it will take a long time, but I want to again to give you to summarize the main information of this slide. So first of all, as you can see, for instance, what can see immediately is that this indicator that I show you here, the definition is maximum value of daily maximum temperature over the period. For instance, reaches very high value, especially in Veneto, Friuli Venezia Giulia, and all the Croatian pilot areas. So values that are very high, they are about for instance, 2.6 in Veneto and 3.5 degree here in Friuli Venezia Giulia. So while also, we have, for instance, consecutive dry days that increase a lot over, are all positive. So it means that the number of consecutive dry days, of course, increase, and then in the future with respect to the past. And then, of course, here we see also that these two indicators, for instance, indicate the number of respectively the number of days per year that exceed the 25, in some exceed the 25 degree, and also the consecutive summer days that have been found. And as you can see, there is a general positive pattern over all these indicators. So of course, these also, for instance, TR, which stands for Tropical Night Index for time period, so where the night exceeds the minimum temperature of the night exceeds the 20 degrees Celsius. So as you can see here, the number of days per year is very high. It's always positive, and it is very high so respect to the past. So if we think that these values are also associated to an increase of very strong events, precipitation events, so that here can be understood having a look to those two indicators, so R95P and R95P tot, which I want to show you here, that stand for percentage time per time period wet days, where daily precipitation amount of wet days above a reference value. In this case, the reference value is calculated the 95th percentile of all wet days. And then the other one is precipitation percentage due to R95 days. So the percentage of total precipitation amount per time period due to R95P. So of course, if we think that those very high value are associated to also very strong dry conditions, first of all, we see that it's clear that severe severe flooding condition may be led by those conditions. So just summarizing this table, we can see that a temperature increase, a clear temperature increase is captured by Adriatic and Wolf data, and then drought condition more severe are found in northern areas, especially in Friuli Venezia Giulia, Veneto, Croatia, pilot area, and also on Puglia. Then also more frequent and extreme precipitation events over Puglia, Marche, Emilia Romagna, and Molise region are found here. This is particularly looking in detail to this table. And then of course, there are more favorable hydrological stability conditions due to combination on dry soil due to less also precipitation events. For instance, this is clear here because of the consecutive dry days and the consecutive wet days, for instance, and in addition with also an increase of the intensity and also frequency of extreme precipitation events. So in conclusion, we can see that temperature differences are strong in Northern Adriatic, reaching maximum value up to 3 degrees Celsius. A strong decrease in precipitation is foreseen in Northern Italy and Croatia. Precipitation increase is also observed over Marche and Puglia, northern sector of Puglia region, and are favored drought and flooding condition in most of the respective region. Moreover, what we also see is that the northernmost region are more sensitive to thermal discomfort. So what has been also observed is that even if precipitation in future decades is expected to decrease, the amount of precipitation associated with wet days increases, so leading to more frequent and strong extreme events. So all this project has been concluded, but in reality, of course, in reality, a new Adriatic Plus has been proposed, has been passed. So actually, in fact, the next month there will be the kickoff meeting, so there will be opportunity to continue all the study and also make some improvements. So thank you all for your participation.
Thank you, Giusy. And so I have, there is one question from Joanna Riedel, which is asking, which is thanking for the webinar and asking if we have open data on long-term daily monthly time series of temperature in the Northern Adriatic Sea. So I guess it's sea surface temperature or ocean temperature.
Yes.
Yeah, please start and then I can complement.
Yes, for sure. So, so in the AirDAP system, several data have been loaded. For instance, for the atmospheric part, for sure, it is available. Are available indicators of temperature over at different aggregation time scales. So both monthly, seasonal, and annual. So also also the related indicators at this scale are available over the for the other components. So especially for the marine part. So Giovanni, if you have something to add, please.
I will just type the answer to Joanna on the chat, so then she can email us and we can send them the link to AirDAP. And also on the GeoPortal, these data are visual. You can visualize the data, but I just type the answer. Then there is another question from Laura Zamboni asking, can you describe the process for deciding indicators with stakeholder in more details? And how are them using them? Are the user using the indicators?
Okay, yes, for sure. Thank you for the question. So, okay, so different meetings have been done with the stakeholders. So, in order to decide together exactly which are, first of all, the main hazard of their region, and then effectively which are the main indicators that are maybe effectively used and used over those regions. So meeting has been done, and the entire task was dedicated to this. So there were a lot of interaction on it. I want just to add something related to this to this answer because as I was mentioning in the presentation, not every partner, every pilot area was able to implement their own indicators, and therefore not for each pilot, even if in the beginning for each pilot area were identified all the hazards, and finally not everyone effectively used all the indicators that were selected for their regions, but they decided finally to use those that were developed at Adriatic scale and at Adriatic scale. But most of them, of course, were provided also at local scale, more specifically in relation to the hazards that have been selected.
Yeah,
so
I'd like to complement that in Adriaclim, most of the regions, or some of them, of the stakeholders and users have started to use these indicators in the adaptation plans that they are developing. There is another question from Alvise Papa. She's asking if you have done some analysis on the solar radiation data.
Nope. Thank you for the question, but no, they have not been used. And yeah, I would say that for sure all possible inputs will be taken into account also for the Adriatic Plus project, because for instance, I would say, just from my simple point of view, is that also other kind of data set may be exploited. For instance, satellite data were more exploited for marine part, but not for the atmosphere. So for sure, even more indicators and data set will be investigated.
Okay. Then a question from Giovanni Farina, asking if you have identified some novel or particularly interesting physical process that can be described, that can describe the observed patterns over the Adriatic region for the indicators. So is there some physical process that are highlighted by the indicators themselves?
Well, I think that the paper published mainly underlined those results that effectively were used. I think that it shows more that the effectively Adriaclim within Adriaclim, the development model were able over the expected period, of course, to capture the mean variability over the past, and also, of course, the values over the future are also incorporated within the cloud of medical, that's the projections that have been run. So let's say there is not, at least from the other for the atmospheric part, I would underline so much novelty, but I think that this is because probably the main novelty is that the model configuration is that there is a so huge modeling setup, including all these different components, and of course this was one of the probably the first attempt in this direction. Probably the novelty is this one, so the configuration. And also I would say that in order to improve also those results, I should, from my point of view, more models would be for sure helpful, also to provide information related to the uncertainty of the model.
Just another question. Can you highlight, is Vera Ramadas asking, which are the atmospheric processes, in your opinion, that are causing the precipitation biases in the northern and southern Adriatic Italy, the southern Italy, to change two distinct signs, so they are opposite? What is the process in your atmospheric process that is driving this, in your opinion?
Yeah. So you mean, can you, I want to open just a moment the question, sorry, just to verify I understood correctly. Okay, are causing precipitation.
Yeah, you have two different behavior in the northern and the southern Italy.
Yeah, sure. So, okay. I hope you can see the slide. I see also the okay, maybe okay. So yes, you have the two different behavior between north and south. Actually, we did not investigated the teleconnection phenomenon correlation with the other patterns also at more broad scale. We didn't do that because this paper wants just to present the main the results related to the indicators developed. So of course this is something that from literature is also so known that it's also it's also reported that northern and southern Italy are impacted by let's say have a more different features related in terms of climate. So the northern conditions are also expected to be drier than the southern part. I will not. I'm not able to give a more scientific answer because they were not expecting this work. So, but of course, it would be really interesting to have and go in detail of these results in a future work for sure.
Okay, thank you. Laura Zamboni has a follow-up question, and she's commenting that it's great that the stakeholder have been incorporated in your results and the indicators and into adaptation plan. But she's asking if the stakeholders and users engaged in Adriatic were only policymaker or also from the private sector, from industry?
Well, they were mainly policymakers.
Yeah, also because the focus was mainly on adaptation plan, but it's also true that in many workshops there was also blue growth stakeholders like aquaculture and marine protected area. So not only policymaker, but mainly them. Yeah, it was mainly at the regional level engagement. Adina is asking if the multi-hazard approach considers only temperature and precipitation extreme.
Sorry, I want to read the chat. Okay, consider only. Okay. Yeah, in those indicators just only focus on temperature and precipitation. Yes. So, but also other indicators. Also, for instance, the wind was also inspected. For this specific publication, we expected only temperature and precipitation, but also other indicators are available related to wind speed, for the atmospheric part. Then for the marine part and biochemistry, of course, there are some even more indicators related, of course, to the more marine and biochemistry variables.
Okay. Well, I have a question myself. You mentioned sometimes in the presentation the uncertainty. So which are the main uncertainties in the data that you have analyzed?
Yeah, thank you. Thank you, Giovanni. So regarding this question, I would say that first of all, since within the project, a single model setup were considered, for sure, in order to also provide a better support to the individual adaptation plans, it would be really useful, for instance, to have a multi-model setup. So this one is already, I think, an uncertainty. So then also resolution probably for some phenomenon may be also may also be increased. and this one is another part. Then I would say that, for instance, also since we had just one single model, so also bias correction technique was applied, but applying bias correction, of course, it contaminates, let's say, also the model, while if we have a multimodal, it is not necessary.
Okay, thank you. Is there any other question from the audience? I check, I think we answered all of them. Well, I think I want to thank you, Giusy, because you were able to present also the complexity of Adria Clim, which is, let's say, was not only a project, but for CMCC was especially an opportunity of really putting in place the multidisciplinary approach. So maybe do you want to comment and explain how this multidisciplinary approach has been considered in Adria Clim, even if it was let's say, a precursor project in this sense?
Yes, this multidisciplinary approach was considered because, of course, the idea was to try to let all the components to interact with each other. In order to have a more comprehensive view of all the phenomena that are within all the phenomena within the climate system. So this was it was very in the beginning, of course, since it is something that has not been done before, it was really complicated because, of course, you don't have so much literature to as reference. So it was interesting to interact with all the other partners for each model component. Everyone, so because of course any partner is more expert in something, so it was really interesting to interact with them. It was to me it was really useful, and I learned a lot from this.
So with that, I think if there is no more question, and I think there are not, then I want to thank you, Giusy, again, and I want to thank all the audience. We were about 80 participants, so a large number, I'd say, and very nice questions and discussions. So really thank you for presenting your results and your activities and the project itself. And I wish to meet you again all in the next CMCC webinar. Thanks again, and bye.
Thank you all.